Okay, in this video, what we're going to do is we're going to look at a couple of examples using the cancellation properties. Okay, and just a review of the cancellation properties, let's take a look at the following. Alright, so what we have here, these are the cancellation properties. And going through these one at a time, we see that the sine inverse of sine x equals x for x in the interval minus pi over 2 to pi over 2. The sine of sine inverse equals x. The sine of sine inverse x equals x if x is in minus 1 to 1. Cosine inverse of cos x equals x if x is in the interval 0 to pi. The cos of cos inverse x equals x if x is in the interval minus 1 to 1. The tan inverse of tan x equals x if x is in the interval minus pi over 2 to pi over 2 exclusively. And the tangent tan inverse x equals x for all x. And just to kind of give you a heads up, if I looked at, if I wanted to memorize these easily, if I already knew the domain and range of the inverse functions and the original functions, and when I refer to the original function, I'm talking about the restrictions on the original functions to make them one-to-one. If we look at the inner functions, starting with 1, we have sine x, starting with 2, sine inverse, cosine x, cosine inverse x, tangent, tangent inverse x. So all these inner functions here, the restrictions are based off of their domains. And so if you knew the domain and range of the original and the inverses, then you should be able to memorize these properties. Okay, so let's go back to our problems. Alright, so here we wanted to calculate these values without a calculator. And if we knew the properties, they shouldn't be too bad. Right? So for this first one, I want to find the cosine inverse of 3/5. Well, this is equal to 3/5 because remember, this inner function, as long as this number is in the domain of the inverse function, and it is, right? Remember, the domain of the inverse function was minus 1 to 1, so since 3/5 is between minus 1 to 1, it's 3/5. Okay. Now, for b, if I want to find the sine inverse of the sine of 330, the problem is that 330 degrees is not between minus pi over 2 to pi over 2, as in the properties. So, what we have to do first is we're going to calculate this. So we're going to calculate that piece. And if we do that, we just simply take the sine of 330. The sine of 330 is going to be negative a half. Just like that. And then we take the inverse of that number. So the sine inverse of negative a half, well, that's going to be negative 30 degrees. Right, that's the answer. So you've got to be careful if this inner function, if that angle is not in the domain of that restriction for sine, then these properties, the inverse and the sine, do not cancel each other out. So if that's the case, as in this case, what you have to do is calculate first and then take the inverse of the value. Alright, let's look at C. Alright, so we want to take the tangent of the tan inverse of pi. Well, we saw that the inverse function's domain is all real numbers. So in this case, for tangent, if the inverse function's the inner function, then no matter what the number is, it's always going to cancel out. And so in this case here, the number is pi. All right. For D, okay, so cosine inverse cosine of 7 pi over 6. All right. So once again, 7 pi over 6 is not between 0 and pi. So what we have to do is we got to calculate this first, and then take the inverse of the value. So if I calculate the cosine inverse, the cosine of 7 pi over 6, that's going to be negative root 3 over 2. And then I take the inverse of that value, and we're going to get negative pi over 6. That's our answer. Okay, last one, E. So now I want to find the tangent inverse of the tangent of negative pi over 4. Alright, well, minus pi over 4 is between minus pi over 2 and pi over 2, the restriction for tangent, right? The inner function's domain. So, in this case, they cancel, and we get back minus pi over 4. Alright, so just remember the domains, and you should be fine. Okay, so next I want to take a look at a couple of other inverse problems, and so let's take a look at these two here, A and B. Now, you might run into this situation where you have to take the tangent of, let's say, the cosine inverse, or, like in B, cosine of the sine inverse. Right. And so in these cases, notice that there isn't necessarily a cancellation property here because, tangent and cosine, they're not inverse of one another, so, there's nothing we can do there. However, the trick here is to recognize that, remember, this still corresponds to some angle. So I can think of the cosine of some angle equals 3 over 5. And then use a relationship between the angles and the ratios, right? So anyway, so now if I think of it, then I want to find the tangent of theta, right? Because I replaced cosine inverse of 3/5 with the angle theta. So now I want to find the tangent of theta. Well, cosine is between 0 and pi, and since the ratio is positive, that means the angle is acute, right? It's going to be in quadrant 1, which means there must be a right triangle, right? And so this is 3, this is 5, this must be 4, and this is theta. So the tangent of theta, if I'm reading off this triangle, should be what? It should be 4/3. And that's the answer. Okay? And so then you can kind of get the idea of what we're going to be doing here for sine, or for B. Same idea. So this here is some angle theta. So that means I want to find the cosine of theta. And if I call that theta, that means the sine of theta and so if I call that theta, that means that the sine of theta is going to be equal to 1/2. Right? So once again I have some triangle, right triangle. Once again it's positive ratio, so the angle is going to be in quadrant 1, so here's theta. And this is 1 and this is 2. So then the adjacent side, I need the adjacent side because now I want the cosine of this, right? So I need the adjacent side. Well, the adjacent side is going to be what? It's going to be 4 minus 1, so it's going to be root 3. Okay, so the answer, well, I guess we could have, if we recognized this was a 30, 60, 90 triangle, I guess we could have done it without all this. But anyway, in general, this is how it can be done. So the answer here is going to be what? Root 3 over 2. Okay, and then our final example for the inverse functions is this one here, where we want to write this expression in terms of x only. So we want to rewrite this in terms of another expression that has only x. Okay. So the trick here is to recognize, if we understand what inverse functions are, this is an angle. And so that means that we're taking the sine of some angle, and that's what? 1 over x. Okay. So that means we have some right triangle, right? And so I don't get in trouble, let me just call this the reference, right? It turns out, just long story short, it turns out that because we don't know what x is, we don't know if this ratio is positive or negative, so it could be in 1 or 4. Remember I had the inverse. Remember the inverse is return angles between minus pi over 2 and pi over 2 for sine. So if you want to try this on your own, I don't want to spend too much time on it, but the idea is that no matter what quadrant we're in, 1 or 4, we end up with the same ratio no matter what. Okay, so anyway, so back to this triangle. So we know that the sine corresponds to opposite over hypotenuse, so this must be 1, this is x here, right? And we want to find the cosine of that, so we need to find this side right here. Well, just using Pythagorean's theorem, this is going to be x squared minus 1. And so the cosine now of theta then would be equal to the adjacent side over the hypotenuse, so it's going to be square root of x squared minus 1 divided by x. And that's our answer.